Hello everyone, this is Mrs. Pagan, and in today's lesson we're going to talk about how to solve for an angle given two sides in a right triangle. Now so far we've asked questions like, what is the sine of A? And you were able to give us a fraction of this answer. Today we're going to continue on a little bit more and we're actually going to find the measure of the angle, in this case A. So let's kind of go ahead and get started, and I want to introduce you to some buttons here. We've so far used buttons like sine, cosine, and tangent on our calculator. Today we're going to use sine inverse, which you can see written in blue, cosine inverse, and tangent inverse. And I'll show you what buttons to press in order to get those. Alright, let's start with this triangle right here. We have two sides that are given to us and an angle that we're looking from. I like to put my eyes right here just to kind of say, hey, I'm looking through angle A. And if I am looking through there, then I know that 3 is my opposite side and 7 is my hypotenuse because it's right across from the 90-degree angle, which means this unknown side is my adjacent. And I'm not going to put too much information on there because I don't know what that side really represents. So I have an opposite side I know and an hypotenuse side I know. Well, the question becomes, what trig identity can I use? Do I use sine with opposite and hypotenuse? Do I use cosine with adjacent divided by hypotenuse? Or tangent with opposite divided by adjacent? Well, I think we all agree that opposite and hypotenuse is needed, so sine would be a good one. So we would say sine of A, angle A, is equal to 3, which is the opposite side, divided by the hypotenuse, which is 7. And we would stop there, but in today's lesson, we're actually going to go a little bit further and actually solve for angle A. So let's go ahead and find out how do we do that. Let's look at example number 1. It says, find the angle with the given trigonometric ratio. Round your answer to the nearest hundredth, I like to underline that, of a degree. All right. We are given cosine of x equals 7 over 19 in number 1. All we have to do is get rid of cosine, and we have x all by itself. Well, the one thing that gets rid of a cosine, and the only thing really that gets rid of a cosine, is its inverse. So here's how we would write that. We would write cosine inverse of cosine of an x equals cosine inverse of 7 over 19. Basically what we did is we took the cosine inverse on both sides, here and here. Well, cosine and cosine inverse cancel each other out, resulting in just x equals cosine inverse of 7 divided by 19. This will actually give us an answer, so we just have to put it into the calculator. But before we do that, make sure that your mode is in degrees. So we're going to go to mode and make sure that degree is highlighted. Now, if your radian is highlighted, then what I like for you to do is go on to the degree, make sure it's blinking on there, and press enter, and enter one more time just to be on the safe side, and then go ahead and quit out of there, and now it should be in degrees. And what we're going to do is type cosine inverse 7 over 19. Now, cosine inverse is right above cosine, so in order to get that blue button, we're going to have to press second cosine. Here's the cosine inverse. Do 7 divided by 19 and close that parenthesis and get our degrees. Since we're rounding to the nearest hundredth, we're going to put 68.38 degrees. And that's our final answer for that problem. All right, great job. So I'm going to change my color a little bit here, and let's look at, this is a pretty color. All right, let's look at tangent of theta equals 101 over 90. Now, theta is the angle. That's what we're going to be solving for. So in order to get rid of tangent, what we do is do tangent inverse to the tangent. And if we do that on one side, we have to do that on the other side. And we put the fraction in parentheses. Well, tangent and tangent inverse cancel each other out, and we're left with theta equals tangent inverse of 101 over 90. And all we have to do is type that into the calculator to find out what theta is. So I'm going to go to second and press the tangent button to get my inverse. and do 101 divided by 90. And that is going to give us the answer. Close the parenthesis, and our answer is going to be 48 degrees, 0.30, rounded to the nearest hundredth place. All right, great job. Let's look at the sine one. So for sine of angle A equals 14 over 21, we want to get angle A by itself. So I'm pretty sure you're already ahead of me. In order to get rid of sine, we have to do sine inverse on both sides. So I'm going to do sine inverse of sine of A equals, I'm going to move it over a little bit, sine inverse of 14 over 21. So we're taking the sine inverse on both sides. And sine inverse cancel out, and we're left with angle A equals sine inverse of 14 over 21. And we're going to go ahead and put that into the calculator by doing second sine and putting our fraction in there and closing the parentheses at the end, pressing enter, and we get 41.81 degrees, rounded to the nearest hundredth place. All right, let's do this one more time to make sure we understand, and then we're almost done. So we have 3 more examples ahead of us. All right, we have tangent of B equals 15 over 4. So in order to get rid of tangent, we're going to go ahead and take the tangent. I'm just going to write the problem. I wanted you to see this, I guess, the way it works in my head. So we're going to go ahead and take the tangent inverse on both sides. And tangent inverse cancel, leaving us with B equals tangent inverse of 15 over 4. And we're going to go ahead and type that into the calculator. Second tangent, 15 divided by 4. And our result is going to be 75 degrees, 0.07 degrees. We're going to round up to the 100th place. All right, let's do this 2 more times. So this one is actually a good one, so let's see it. We have sine of A equals 1.2. To get rid of sine, how do you get rid of a sine? Yes, you have to do sine inverse on both sides. Notice that the inverse is always on the left side. Sine and sine inverse cancel, and angle A equals sine inverse of 1.2. So let's check that out. Second sine inverse, 1.2. We're going to close that parenthesis, and we got an error message. It says error, domain, quit. All right. So if that ever happens to you and you don't get a result, we say that the angle A is undefined. It does not exist at that location. Therefore, we cannot find it. That triangle really does not work for us. All right, so if that ever happens, please write undefined. All right, last one. We have cosine of theta equals 65 over 76. So we're going to just go ahead and write this problem down. And on both sides, to get rid of cosine, we're going to go ahead and do cosine inverse. I'm trying to change my color, but... All right, so cosine, here we go, cosine inverse on both sides. Cosines cancel, and we're left with theta equals cosine inverse of 65 over 76. And theta equals, let's do this, clear. Second cosine gives us the inverse, 65 divided by 76. Close the parentheses, enter, and we get 31.21 degrees. And that's our final answer. All right, now go ahead and head to the tables and work on some in-class practice. It should not take you longer than maybe 5 or 6 minutes. Check your answers and then take the quiz. Great work today.